So today we'll speak about the embedding models. We will briefly talk about what embedding models are there, what are the benchmarks, what are the best embedding models, and then we'll go into our research that we are working on about training the embedding models for Armenian. So let's start. I think most of us familiar what embeddings are. So it's just basically transforming objects into numbers, into an array of numbers. And there are multiple ways of doing that. And one of the ways is the traditional word-to-vec or glue, in which case we convert each word to a series of numbers, and then every time, whenever we see that word, we just replace with its representation. So we all know this case. If you subtract from king, queen, and then add man, you will get woman, I think. But the issue here is that there are a lot of words that can mean multiple things in different contexts. So just the word embeddings and the word representation will not catch that. So one of the examples is the word left, which can mean the side left and also the leaf. So if we just use the word embedding for that word, we will get the same representation, but it will mean different thing. And the other way of representing words is the contextual embedding, in which case we will generate the word's representation depending on the context. So it means we have three different sentences, and the word may will have different embeddings in each sentence as it's depending on the context. And this is good, as we will always have the word's representation depending on the context, and even if the word has different meanings, we will catch all of them. So the current state-of-the-art embedding models are, one of them is E5. The name comes similar to T5, where in the name there are 5 E letters, so they just took and make it E5. And this model is from Microsoft. And here they just took the traditional BERT and collected the data from different sources, from Reddit, Common Crawl, Stack Exchange. They did this filter called consistently based filter, in which case they first trained the model on this noisy raw data, and then they used that same model to rank the existing pairs. And then from that ranking, they ended up with 270 million pairs. And then, so this 270 million pairs is a cleaned version of this data set, which they call CC pairs. And they then just feed it to the dual encoder with query and passage added in front of the data. And they just took the cosine similarity and so here this query and passage is very important, as this means that the training is asymmetric, and for some data sets it was very hard and not so straightforward what should be the context and what should be the query and what should be the passage. So they ended up with randomly flipping the places of query and passage, and that improved the performance of this E5 model. And there are a lot of variations of this E5. They trained E5 multilingual and different sizes. So this is one of the best models. The next one is GTE from Alibaba. They actually have different versions of this model, and there is even one with different name. The main important part is that they did the training on 2 phases. The first unsupervised pre-training, and then supervised contrastive fine-tuning. And here on this pre-training, they just took the CLS token of the MLM. So they just trained MLM models, took the representation of that CLS token, and then computed the cosine similarity and the loss function on that pairs. So here we don't have that explicit query passage. So in this training, it's symmetric. So it doesn't matter if you flip the places, it's going to be the same thing. Yeah, and then they just did the contrastive fine-tuning with info and C loss on these multiple data sets. Yeah, and here they also trained this model on with two parts. So the first stage was training the model on 2000 model length, and then they retrained the same model with same data but with 8000 model length, which improved the model and enabled them to have bigger context. So if they were just starting to train with 8000 token, it would be very hard for the model to start understanding and taking understanding this big context. So they started with 2000 and they retrained it with 8000. So there is also this trending large language model embedding models, and so yeah, sorry, I had to. My slides are a bit broken, but you can see that this is this 0 represents the starting token, and then this 2 is actually the end of sentence token, and this is the token of these words, and this is the representation. So the main point of these large language LLM models is that while training, they just take the end of sentence token embeddings and then use it for the whole context. So if you have query and passage pairs or just two sentence pairs, you would ensure that you have end of sentence token in the after tokenizing, and then you would take the end of sentence token representation and compute the loss and the rest on that. And one of the popular models is E5 Mistral. So they just took the base E5 model and trained the Mistral model on this. And the E5 part, I think, is important as before it was already trained on query and passage pairs. So the model already defines and can distinguish between query and passage. And in this case, they also added more instructions. So the first initial query that was fed into model, they replaced it with instruction. So they generate a few words instruction about the query, and then calculate the loss, which is the info and C loss for contrastive learning, and they calculate this loss on this new instruction and the same passage that they had. Yeah, and the phi is just the temperature scaled cosine similarity function. Yeah, and the cosine similarity function on this bottom part about the sum is for the negative. So in this case, they use in-batch negative examples and also hard negative examples. So they basically already have defined the negative examples for pairs, and for each query and passage pair, they treat the rest of the rows in this batch as negative examples. Yeah, and so this Mistral part is just how the paper was written, but this E5 Mistral approach also works with the other models, and we actually are working on this. So this is the evaluation from E5 Mistral, and as we can see, this E5 Mistral beats almost all of them in all of these, I think it's MTAP benchmarks, and So they also trained it on synthetic data generated from ChatGPT and also on the full Wikipedia and Reddit data. So here we can see the GTE E5 models that are doing all right, but not quite good as the E5 Mistral. Yeah, and just to show what is it looking in the MTEB benchmark. So MTEB stands for Massive Text Embedding Benchmark, and it has different categories. So this is just the average benchmark for all of them. And as you can see, the first model is NV-Embed from NVIDIA. I think it's also a Mistral model trained with this same approach as E5 Mistral. There is this other good model called BGE, and then the rest are all GTs or E5. So this Stella is GTE model. I think this is from Salesforce model, also similar. Then GT, 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 and the rest are all either GTs or E5s or Mistrals. Okay, so the applications of embedding models are very important. Obviously, one of the basic applications is you can build sentiment analysis if you have a good embedding model. You can create a RAG system, which is very popular right now. Obviously, you can also use not the embedding model, but some language model and just take the embeddings from them, but it's not ideal as the specialized embedding models are more efficient and usually work better. You can also have some recommender systems, and I think the best and the most important one is you can use the embedding models to prepare data for large language model training. And in the Llamas 3.1 paper, they use the embedding models all the time to filter out the data, to prepare it for training, and the Llama 3.1 and the use of embedding models shows very good success. So this is one of the biggest motivations that we think that Armenian embedding model is very important, and we should have very good Armenian embedding model. Yeah, okay, so let's talk about the elephant in the room. Let's talk about what we are working on. Currently, we are working on pre-training in the unsupervised way, embedding models for Armenian, and we gathered some amount of data. So the public ones are Wikipedia, Common Crawl, and also there is RLIS, which is for government documents. Common Crawl, we actually use a different version of Common Crawl. It's called C4, which is just a cleaned version of Common Crawl, and then the Wikipedia. And from the Common Crawl, we took only the news dataset, as we were having some overlaps with Wikipedia and RLIS. So our whole training data consists about 200 million tokens, which is actually not a lot, as if you compare it with English tokens, it will be about a couple billion tokens. So 200 million is not a lot, but that can be a good starting point. And then we also have some validation data, which is just the scraped data from iLure, which is another news website. And here in this iLure, we have just the sentences of that website, and then we also have the category, what website it is. So there are 7 different categories, and we use this data set as classification metric in our evaluation. We have the ARPA, which is I think another website scraped dataset, and it is mostly so this ARPA is for paraphrase. We have 2 sentences and then a flag indicating if it's a paraphrase or not, and we have the -1, 0, and 1 indicating if it's paraphrase, near paraphrase, or not a paraphrase. And then we also translated this MT-MTEPS STS dataset, which is we have 2 sentences, and then we also have the score, how similar these 2 sentences are. So we have starting from 0 up to 5 continuous numbers, and for each one we have how relevant are they. And as you can see, this translation is not ideal, as it was translated with Gemini, I think, and usually when using translated datasets, it's a good thing to avoid using translated datasets. But in this case, we think that it's not going to hurt, as the context is going to be the same, even if there are some grammatical errors or some non-meaning words, but the context is always going to be the same. So if 2 sentences are completely irrelevant, then their translation is also going to be irrelevant. Here, and we trained the E5 Mistral. We trained the model with E5 Mistral approach, and we just replaced the Gemma with Mistral, as this just worked better for us. And we actually have different other models, but this one is just the best among our all trained ones. And then we have blue, our model, and then on the red we have the multilingual E5 without any training. And here is our evaluation on our dataset. So we have top accuracies, precision recall, and also the MRR for more recommender metrics. So as you can see, we have our Armenian Gemma is doing mostly better on this ILUR classification dataset, but for the others it goes a bit behind. So this was for the ARPA's paraphrase dataset, and it's close, but the multilingual E5 is just better for this task. And then for the STS, we also have we are a bit behind. So, and also, just as I said, our training dataset consists of 200 million tokens, and this Gemma model is not going to be the final model. And there are some improvements that we are working on. Yeah. So the key takeaways from our research are that the multilingual embedding models are crucial for low resource language models, and these top models are working really good with limited data, the BGE, the E5 and GT, and even without any training, they are already doing very well. The Armenian embedding model will enable us more flexibility and better Armenian model. So, and this foundation embedding models can be foundation for advanced systems such as RAG systems, spell checkers, autocorrects, and voice assistants for Armenian language users. Yeah, and we are, as I said, this is a research project, and if anybody would like to collaborate with us, we're happy to share our model if you would like to use it for non-commercial use cases. And if you have any questions, you can feel free to reach out.
Thank you very much for the talk. I'd like to know how you choose how to initialize the weights. I'm asking this because to initialize the weights. Let's say if you do that with some large embedding models, which was trained previously on English or Spanish language, it does not provide the same results if you find models similar to Armenian language, let's say Russian or Greek language. Those might actually improve the results. I would like to know your thoughts.
Yes, so for this Gemma model, we just took the existing pre-trained Gemma, as it already had abilities to generate in multiple languages, and also these multilingual models, even for the GT or E5, they are trained on about 70 languages, so which Armenian is included on them, but the vocabulary for them is small. So for the E5 or GT, there are about 800 Armenian tokens, which is not a lot. So I think if the data allows, if you have data, more than 200 million tokens, then just training from zero should be better, but just training on scratch with tokenizer and the model. But with limited data, usually this just continuing the pre-training works better.
And what about number of unique tokens, and what kind of tokenizers did you use? Character level or word level tokenizers?
So we are using the character level for the Gemma. We also try to train our own tokenizer, but it was behind this Gemma. So we ended up with character level tokenizer.
And number of unique tokens, how much was it?
So number of unique tokens, I think we have around 4,000 Armenian tokens.
Yeah, thank you for the interesting talk. I was wondering, you say that you have 3 validation data sets. So in one data set, Armenian Gamma embedding model means multilingual E5. For the other data sets, the performance were close. Do you have any idea why kind of that happened? Is the first data set simple, or why was the result like that?
So our intuition behind this is that this is a classification data set where we have tags and then seven different categories. So we're thinking that just Gemma does this classification task better, and also the labels of this classification are just one word instead of whole big text as the multilingual E5 was trained on. So that could be one of the reasons why we succeeded in this. And then the rest, I think we're behind just because of the data and the size of the data, and we believe that with bigger data we will just pass this.
Thank you. Thank you for the talk, and obviously it intersects with my next keynote. I'll promote that, but we'll talk about mean initializations too. But I had a question. Obviously you rely on the innate abilities of Gemma and E5. Have you tested, basically compared the Gemma's performance in REG type of context and any existing benchmarks for REG compared to your model?
No, we have not, but that's in our roadmap to do the next on the list.
Awesome.
Thank you.
Okay.
Thank you.
Let's thank the speaker.